Chapter 15, question 8 says identify each of the following processes as hydrogenation, hydrolysis, or saponification, and give the products. You don't have to worry about B. A says talking about the reaction of palm oil with KOH, that's potassium hydroxide. Okay, so palm oil is a fatty acid made up of fatty acids, and so it has that long hydrocarbon tail, and then on one end you'll have the acid, the carboxylic acid. And so it is an organic molecule. It's made up of carbon, and it'll undergo the same sorts of reactions that we saw molecules undergo in the organic chemistry part of the course. Reactions like hydrogenation, hydrolysis, or saponification. Remember, hydrogenation was a reaction in which you added hydrogen. You would usually start with a double bond, you'd erase the second bond, and you'd add a hydrogen to each of the carbons that was involved there. So you added a hydrogen molecule, H2, to the carbon backbone. That's hydrogenation. So we'll recognize hydrogenation by H2 being one of the reactants. Hydrolysis. Hydrolysis is where you add water, hydro, like you keep hydrated, you drink a lot of water, to a molecule, and it would break apart. We saw that in the case of esters. If you have an ester and you add water, it'll break that apart, and you'll get a carboxylic acid and an alcohol. So carboxylic acid and an alcohol, like that. So that was hydrolysis. So we'll recognize hydrolysis because water will be present. So we'll recognize hydrogenation by hydrogen being present. We'll recognize hydrolysis by water being present. And then saponification. Saponification is where you add sodium hydroxide or potassium hydroxide to oils. And that, we saw this in the when we had the reaction of carboxylic acids with, say, sodium hydroxide. The H from the carboxylic acid and the OH from the hydroxide come together and form HOH, or water. So those go to form water. And what's left is the sodium and the oxygen. Now the oxygen technically has a negative charge and the sodium has a positive charge, and that's what makes those attract. Notice though that this end of the molecule is now really, really polar. You have, first of all, you have lots of partial charges, but you have full charges. The full negative charge on the oxygen, the full positive charge on the sodium. You still have the nonpolar fatty acid tail, but we have two. When you treat these fatty acids with sodium hydroxide or with potassium hydroxide, you get two parts to a molecule. A really polar part, really polar, and a nonpolar part. And that is what you need to make a soap. Let's say you have your skin, so that's your skin right there, and some grime and oil. Your skin secretes oil, and in that oil, you go through the day, whatever, there's a bunch of dirt that'll get stuck in it. And so you have that dirt on your skin. Why can't you, the oily dirt on your skin, why can't you just rinse that with water and wash it off? Because water is polar, and the dirt is in oil, which is nonpolar. So the water would just roll off the oil, and the oil would, with all the dirt and microbes and whatever, would stay on your skin. If you take a shower with no soap, you're just washing water over you, you're not getting rid of all the dirt and microbes that are on your skin. So, you add soap. And what soap does is the nonpolar end of the molecule will mix with the nonpolar oils. And the polar end will be able to mix with the water. So now you have these tails that are acting almost like anchors. They sink into the oil on your skin, and now when you wash water over your skin, it tugs on the heads, and the whole thing washes away as a unit. And so you're left just with your clean skin. So, you can make soaps. The big takeaway from that is that you can make soaps by adding potassium hydroxide or sodium hydroxide to fatty acids. You can take fat from humans, from other people, or from other sources, from oils, from plants, and you can treat it with potassium hydroxide or sodium hydroxide, and it'll make these molecules that have a nonpolar tail that mixes with the oil on your skin, and the polar heads that'll be pulled along by a current of water, and that'll clean your skin and make a soap. And the fancy way of saying that you're making soap is you're saponifying something. You're doing saponification. So you saponify stuff, you make soap when you add sodium hydroxide or potassium hydroxide to a fatty acid. And so that's how we would recognize saponification. All right, well in A, it's talking about the reaction of palm oil, which at this point we would know nothing about. We wouldn't have that memorized. The reaction of palm oil with, and here's the key term, potassium hydroxide. And we see that potassium hydroxide leads us to saponification. Because we're adding potassium hydroxide, we know that A is talking about saponification. And the problem is just asking us to identify which process is going on. So saponification is going on. That's the answer for that.